Okay, the next concept here we're going to talk about is the point that we're dealing with a fluid, mainly refrigerant, that's going to be either in the liquid form or the vapor form. So to simulate that, I'm boiling a pot of water on the stove. You can see with a thermometer in it. And as we get closer to the 212 degree mark, we're going to see that water boil off. Quite honestly, what we're going to be working with is refrigerant that is right on the borderline of boiling into vapor. So if we remove a bit of heat from that refrigerant, it's going to turn to liquid. If we add a little bit of heat to that, it's going to turn to steam or vapor at that point. Those are the two states that we're dealing with in refrigerant. Is going to be obviously in vaporized or in liquefied form. And we will never really have situations, if you will, where we're dealing with it in solid. If we do, we've got a real issue. But you can actually see here that the temperature of the water is coming up as we go. We're at 207 degrees. And then we're going to start to see the rolling boil coming up here as it warms up. Now the crazy thing is, once this water starts boiling off, and we can start to see the rolling boil. Now our thermometer says 209, 210 degrees. Really, the water should never get hotter than 210 degrees because we don't have any way of really capturing or measuring the steam temperature. So the water temperature basically would be 212 degrees. 210 is probably just an error on my thermometer. Wouldn't surprise me. It's a fairly old thermometer at that point. Yeah, you can see you got a 211. We'll see if it gets any warmer than that. So obviously the water is starting to evaporate off now into steam, so it doesn't take anybody with a lot of technical sense to realize the longer we leave this, the more that water is going to boil off into steam. And that thermometer is never going to get warmer than the 211, might go to 212, but it's not going to keep climbing. That's as high as it's going to get. So one way we can change the boiling point of water is by increasing the pressure over the water or decreasing the pressure over the water, depending which way we want the boiling temperature to go. So a pressure cooker is a prime example of something that you can use that helps food cook quicker. If we put pressure above the water, we're going to increase the boiling temperature of the water. Because right now, if we had a food product in that pot, as a prime example, we would only be able to cook it so quickly because the maximum temperature of that water is always going to be 212 degrees. If we put pressure on top of that water, now we're going to increase the boiling temperature, which means that it's going to cook the food quicker. So a pressure cooker concept, if you will definitely decrease the amount of cooking time required for that application. The big wave with Instant Pots, a prime example, is going to be pressurized cooking, and that's really what it does. It cuts down on the amount of time that you need to cook something because of the pressure that's on it. So this is a kind of a good way, if you will, of observing this phenomenon of the boiling temperature.